Hi there, in this video we're going to do some examples in order to convert the vector equation of the line into parametric and Cartesian form, okay? And we're going to use the pattern that was explained in the last video. So if you looked at the last video, so if you watched the last video, I went through how to get the parametric and Cartesian equations of the line using the vector equation. But not only that, I also gave the pattern relating the three forms. So let's try an example using the pattern. So example number 1. So the question being, so I hope you can see that. So the question being writes down the parametric and Cartesian equations of the following line. With vector equation So the vector equation of the line is given by r is equal to I plus 2j plus 3k plus lambda into 2i minus 3j plus 5k. So that is the vector equation of the line, and we need to write that in parametric and Cartesian form. So if you watch the previous video, so this is the vector equation of the line, this is what we call the direction vector, and this is the fixed point vector, or the position vector of a fixed point on your line. So remember, with regards to the components of the direction vector, A2, B2 and C2, they should relate to A2, B2 and C2 in these parametric equations, and the components of the position vector of the fixed point on your line, A1, B1 and C1, that should relate to A1, B1 and C1 here. Okay, so let's use that relationship and get the parametric equations of the line. So in this case, for the parametrics, we're going to have x is equal to, so A1, which is the coefficient of I here, is 1, okay, and the coefficient of I in the direction vector is 2, so it's going to be a plus 2 lambda, okay. So that is the first equation for x, okay, using that relationship. So the equation for y is equal to, so firstly, the coefficient of the unit vector j in your fixed point vector is 2, and the coefficient in the direction vector of j is minus 3, so it's minus 3 lambda. So that is the equation for y. Finally, the equation for z, so z is equal to, the coefficient of k in your fixed point vector is 3, and the coefficient of k in the direction vector is plus 5, so plus 5 lambda. So these three equations, using the relationship, these are the parametric equations of the line. Okay. So, and if you want to work out the Cartesian equation, so let's go back. So remember, this is the vector equation. In order to get the Cartesian, so Cartesian is one equation for x, y and z only. A1, B1 and C1, so again, provided that there's minuses over here, so provided that there's minuses over here, A1, B1 and C1 come from your fixed point vector. So the components of your fixed point vector will be A1, B1 and C1 in your Cartesian equation. So let's write down the Cartesian equation. So therefore Cartesian equation, so it will be x minus, okay, so coefficient of I is 1, so it's a plus 1. That's equal to y minus coefficient of j is plus 2. That is equal to z minus coefficient of k is 3. Okay, and we need to divide that by, so going back to the relationship again. Now looking at the direction vector, the components of the direction vector, a2, b2 and c2, those will appear in the denominator. Okay, so those will appear in the denominators when you write down the Cartesian equation. Okay, so a2, that will be the denominator of the x expression, so x minus 1 divided by component of I in our example. So in the direction vector here in the example is plus 2, so x minus 1 over 2. That is equal to y minus 2, coefficient of j in your direction vector is minus 3. That's equal to z minus 3, coefficient of k in your direction vector 5. Okay, so this is the Cartesian equation. Okay, so that is how you would get the parametric and Cartesian equation for the line using the relationship, but you could equally go through these steps again as I explained in the previous video, using the example given in order to get the parametric and Cartesian equation as well. However, if you know the relationship, you can write down the parametric and Cartesian equations very quickly. Okay, let me go through another example. So in example number 2, let's take a red pen and underline that. In example number 2, let's start off with the Cartesian equation and then write down the vector equation of the line. So if we're given the Cartesian equation, so given the Cartesian equation of a line, so I hope you can see that. So the Cartesian equation is x minus 5 over 7. That is equal to y plus 3 over minus 5. That is equal to z minus 1 over 2. So, so we're given this Cartesian equation of the line. So write down the vector equation of the line. So write down the vector equation. Okay. So if we go back to that relationship as explained in the previous video, okay, starting from this Cartesian equation, remember provided that there's minuses here, a1, b1 and c1, those will be the components of your fixed point vector, and the terms in the denominators, a2, b2 and c2, those will be the components of the direction vector. Okay, so the reason why I'm stressing there should be minuses over here is, so in our example over here we have a y plus 3. So first of all, let me rewrite this as, so x minus 5 over 7, so there's already a minus sign here. However, y plus 3 over minus 5, I'm going to write that as y minus 3 over minus 5. Okay, and that is equal to z minus 1 over 2. So I have minuses here. So that means that if I write down the position vector of the fixed point on the line, so forgetting about the minuses here, so we're going to have 5i minus Okay, so be careful. So minus 3j plus 1k. So just ignoring these minuses here, using these terms, write down the position vector of the fixed point on your line. So I call that A. Okay. Now the vector parallel to your line, or the direction vector M, okay, so the components come from the denominators as I explained. So writing down the direction vector straight away, that should be 7i minus 5j plus 2k. So that should be your direction vector straight away. Okay. And knowing the position vector of the fixed point on your line, knowing the direction vector, you can write down the vector equation of the line. So let me continue on the reverse. So in this case, vector equation of the line, remember the formula wise, R equals A plus lambda M. So if I substitute what we have, so the position vector of the fixed point A, we found to be 5i minus 3j plus k. So 5i minus 3j plus k plus lambda into the direction vector M is 7i minus 5j plus 2k. Okay, so 7i minus 5j plus 2k. And that is the vector equation of the line. Okay, so that completes this video. I hope you found this video helpful, and I hope to see you in the next video. Thank you.